Hello, everybody. I would like to go through one problem from your textbook. I would like to go through problem 10.12 from page 358. I have to read this problem very carefully and see if I can determine what kind of procedure to use. And so when I look at this problem, it's dealing with the bank with the branches located in a commercial district. So based on these branches, we take 15 customers as our sample, and we measure the waiting time that they needed to wait until to be served. And we try to duplicate the same thing for another branch in the residential area, again with 15 customers selected randomly, and we measure the time they need to wait until to be served. So we like to find out if, assuming that the population variances from both banks are equal, is there evidence of a difference in the mean waiting time between the two branches? Use alpha as 0.05, and then we need to determine p-value and find out what the meaning is and what assumption would be needed in order to do this kind of problem. Let me go to PowerPoint and show you my general approach to this type of problem. And the very first thing I'll do, I try to find out if it's about the mean of a population, or it's about proportion of a population, or it's about other things. So clearly this problem is about the mean of a population. And the second thing I need to do is about what is this problem is about one population, or if this problem is about two population, or it's about more than two population. Again, I have no problem with this one because I know I have two populations. Next thing I need to do is I need to determine if this type of problem I am dealing with is independent or unrelated one, or would be dependent or related one. So since this problem, uh, when I'm reading it, I could find out that, oh, dealing with two districts. One is residential district, one is uh, commercial district. So these would be considered independent case. So right now I'm dealing with the test of hypothesis about mean of two population to independent population. And lastly, I have to decide here if it's a one-tail or two-tail test. Again, this is not going to be easy one, this particular one. I have to read the problem and see what the problem is really asking. So if I go back to the problem, I will be able to determine this one. So when I go back to the problem, here, right away here it says, is there evidence of a difference in the mean waiting time between the two branches? As long as it says if there is a difference, the difference could be more than or could be less than, it means it could be okay. If it would have said that if one uh, area's waiting time is more than the other, then we will do one tail. But right now, clearly, this is a two tail. So let me go back to PowerPoint and try to formally go through this. Uh, I know I'm dealing with test of hypothesis, mean of two independent population, two unrelated population. So always I am going to have that step one, HO, mean of the first group is the same as mean of the second group. For this particular case, I have mean of the first group is different from the mean of the second group. So it means mean of the first group is not equal to the mean of the second group. And then I go to the third step, I've got to make sure that I know the size of each sample. Remember, size of each sample would be, in this case, would be 15. So I could determine my degrees of freedom. In this case, would be uh, 15 plus 15 minus 2. It's going to give me 28. And I can look at the level of significance, alpha is 0.05, and determine my critical value. As long as I am using different statistical software, I may be able to skip this one and right away try to make a decision based on what is known as the p-value. So I'm going to try to use that approach. So now I'm going to go to computer software. Let me go to StatCrunch and perform tests. So I'm going to go back to Pearson site. And over there, I try to access StatCrunch. Now, when I try to use StatCrunch, it gives me two options. One is if I'm going to use data set from my textbook, which is a very fast one. Also, I could try to try to save the data somewhere and then load that. Let me use the second one since I already save my data. And so I try to use this, and I already store data on my computer. So I'm going to go to this option. Uh, I have to go and locate my file. And sure enough, I already have stored my data as Excel file. I could basically try to upload that. And right now it's on the website, but I could try to make it available to StatCrunch. And now it's trying to upload it, and right now I have the data. So I'm going to try to use a statistical test now. It makes sense to go to Start, and I'm using a t-test. Remember, I already know I have a two population, so I go to do two samples. And I already know the data available, so I go to this one. So when I go to this one, wants me to identify my first sample. Obviously, it's the bank one waiting time. And my second sample is bank two waiting time. And remember, I'm pulling variances. Actually, the problem even told me that, so I have no issue with this one. Now, under HO, mean of the first group is the same as mean of second group, is mu1 minus mu2 is equal to 0. Under alternative, mu1 minus mu2 is different than 0. It means their means are different. So right away, I don't have to change anything. If I had a one-tail test, I could have done it this way and change it to one tail. But right now, I don't have to make any adjustment. So right now, all I need to do to go ahead and let computer to calculate. So it's going to go through. Under HO, mu1 is the same as mu2. Under alternative, mu1 is different than mu2. And right now, I know my statistical test value is minus 4.13. Better than that is my p-value. My p-value is 0.0003. Remember what I have here very easily. I could take it to Microsoft Word by copying it, or I could save it and later on to use it. So depending on what I want to do, I can take these to Microsoft Word and right away make it available there. Now, let me make a decision here. Remember, my p-value is 0.0003 and my alpha is 0.05. So I'm going back to PowerPoint. I'm comparing my p-value with my level of significance and make a decision. Obviously, my p-value is very, very small. My alpha was 0.05, so in level of significance, alpha is more than my p-value. I reject. I'm going to reject HO. So basically, I'm rejecting HO. Therefore, this is what I am saying. And the mean of the first group is different than the mean of the second group. The mean waiting time in a commercial district is different than the mean waiting time in a residential district. So this would be my conclusion. And remember, alpha is the same as level of significance. It's 0.05. And 0.05 clearly is more than my p-value, which was 0.000. And now, if you have any question, please let me know, and you can send me email. Thank you for your attention.